Welcome to Spring LIB.
All right, we're looking at question 28.52, and here we have a solenoid that's a toroid. So the formula that we want to use to calculate the magnetic field is normally this one up here, the top one. But since we have, we're told the relative permeability of the core, we're going to want to use this expression instead, where we're replacing this mu naught with Km times mu naught, where Km is this relative permeability. We have, let's take a look at the information that we're given here. We have the number of turns, we have the radius, which I'm just going to convert to meters here before we do anything, so it'll be easy to plug in. We're given the current and we're given this relative permeability. So all we really need to do here is just plug in all these numbers that we have. So we have Km, the permeability of free space, N and the current, and then divided by 2 pi r, and r is going to be our 0.06 here. So when we plug this all in, we should get that B is equal to 0.0267 Tesla. That's the answer to part A. Now, part B asks the amount due to atomic currents. So that's an interesting question. And really, it's the amount due to atomic currents can be found by just taking the difference from this result that we got here using this formula, the difference between that and the result where we have, where we don't have any permeability, where we're not considering this relative permeability. So when we just use mu naught here instead of Km times mu naught. So the easiest way to really do this is if we consider this all, let's call this B1. We want to find the difference between B that we just found and B1. So we're taking B minus B1. And since we have all of this over here, we can really just write, since all of these constants are all the same, we can just write that B is equal to Km times B1. So we're just trying to take Km times B1 minus B1, and that's going to be Km minus 1 times B1, just factoring out this factor of B1. And Km minus 1 is going to be 79, and 79 times B1, which we have here, if we again just plug all of these numbers in, that's going to give us this value for B1 here. And this should give us, when we calculate it, 0.0263 Tesla. So this tells us that the amount due to atomic currents is going to be almost the entire thing here, 0.0263 Tesla. So this is part B.